Hi college algebra student, this video is for chapter 5.7 inverse function part 2. So last time I talked, in part 1 of the video I show how you can find inverse of a polynomial as well as a radical function. Mainly they are actually just a full cube root or cube or an x squared term and a cube term. Now I want to show you where I have a polynomial that has both an x squared and an x term. So how to find inverse? Because these are a little more difficult. So what we can do is we will let me get the pencil up first. So this one has an x squared. I should write it as x squared. Oh gosh. X squared plus 4x like that. So this is g of x. So and then we were given the domain as from -2 to infinity. So this is what we have. So we want to find the inverse of it. So if we restrict it from -2, if you graph this function in decimal, you'll see that it is a one-to-one function. So let's do all the 4 steps. So first is to write y equal to x squared plus 4x. The second step is always switch x and y. X is equal to y squared plus 4y. Now the following step is what we should usually do is just solve for y. But you see how it is difficult because we have a y squared term and a 4y. So there is no, even if I factor the y out, there is another y. So I can just divide it to have a y equal without y on the other side. So the trick here is to do completing the square, make this a square term. So I would write 4y. So what is missing so that this is a square? It would be, remember the completing the square method. So you add 4 on both sides. This will immediately become a square. How do I know it's 4? So you divide 4 by 2 and square it. Is this 4? So this is actually 4 divided by 2 and square. That's what we usually do. We look at the coefficient of the y term and then divide it by 2 and then square it, become 4. So I have to add 4 on both sides. So now this will become y plus 2 squared if I factor it. So it's x plus 4. Now you can see I can, instead of dividing or factoring, I do square root on both sides, x plus 4. And because my domain is x has to be always greater than -2, so this would always be a positive number. So when I do a square root, I do not have to do the negative one. So this would be equal to y plus 2. Right? It's always a positive number. So if you start from -2, 3, 4, so these are, always positive. So I just take the positive. And so to solve for y totally, you minus 2 on both sides. So it'll be x plus 4 minus 2. And so the last step, fourth, is to write the inverse. This is a g of x. So g inverse is equal to the square root of x plus 4 minus 2. And you can also see that what is the range for this? The range for this is y has to be greater than equal to -4. If you use decimal to graph it, so this fit the domain here. X has to be greater than equal to -4. The next one is find the inverse of a rational function. We have gone over this in 3.7, but just a little bit more detail. So usually we would look at the domain and the range of this function. We want to know the domain because, that would become the range of the inverse. The domain would be x cannot be 2, right? Oh, cannot be -2. So otherwise you'll make this not work. And then we also have to find range. What is the range of it? You can graph it. You can graph it to see what the y value will take. And if you graph this, you can see that there is a horizontal asymptote of y equal to 1. It is a horizontal asymptote that's not touched by the graph at all. So y cannot be 1. The horizontal asymptote is the degree is the same, so it's leading coefficient 1 over 1, right? And it would help us to find the range. And if you don't know, you don't want to find the horizontal asymptote, you can actually graph it to find out domain and range. Let's use the space, x minus 1, x plus 2. So then once we do that, then we're going to do the solving part. Step 1 is y equal to x minus 1, x plus 2. Is that right? I think it is. Let's double check. X minus 1, x plus 2. And then the second step is always to switch x and y, right? So I have x equal to y minus 1 over y plus 2. Now I have to solve for y. To solve for y, we have to isolate all the y term on one side. So multiply y plus 2 on both left and right. So the right hand side will have no y plus 2 because it would cancel. The left hand side would have xy plus 2x and then y minus 2. We want to have all the y term on one side. So let's move this y over here. So xy minus y equal to negative 2 minus 2x. And we'll have this move to the other side. So basically, so then we have to factor x minus 1 equal to negative 2 minus 2x. And then the last would be to do y equal. It would be negative 2 minus 2x over x minus 1. And if we want to get rid of the negatives to make it as a 2 plus 2x, I can switch this to opposite also, 1 minus x. So then the g, is it a g or f? I forgot. F inverse would be equal to 2 plus 2x over 1 minus x. And you can see that the domain is you cannot be 1, right? X is cannot be 1, which fit what the range was. So this is how you find the rational function's inverse. We have two applications that I want you to do. The first application is to write the height function using the height function and write a function of t as a t function. So we have been using t as the input to find height. Now we want to use h as the function, as the input to find t. So we would do the same thing. So, but instead of x and y, it become a little strange. It would become h is equal to 500 minus 16 t squared. But I don't need to switch. I really just want to solve for t. So to solve for t, I would have h minus 500 equal to negative 16 t squared. And here, t is always positive because t is time, right? So then I would want to do t squared by dividing both sides by 16. So again, this is step 1. This is solving. We don't need to switch x and y, so this is step 3. So we keep the h and t because we'll just keep the same variable. And so this is divided by negative 16. And then we are going to do a square root. So because t is positive, so my when I do the square root, I only need to do the positive one. So this is how I would do it. And you can also see that h has to be greater than a number, right? So I would say t of h, this is the function, is square root of h minus 500 divided by negative 16, and it's positive. So this is how we express it. So this is the fourth function. And then to do this, find the time to reach height of 200. So when height is 200, I'm going to plug in, right? So t of 200 would equal to square root of 200 minus 500 over negative 16. So the top is a negative, the bottom is a negative, so you would have a positive inside, so which you can do square root. So it will be a square root of negative 300 divided by negative 16, and so it will be 4.3. So at 4.3 seconds, the object will fall to the height of 200 feet. The last work problem is about pendulum. So this involves a function like this. If you have a length and you put something at the end of a length of a string or something, and then you have it string string back and forth, then the period would be the time for the object to swing to this side and then back is called the period. So for a certain length, you can calculate the period this way. So T of L, let's write it again. It will always strain because of gravity, 32.2. And someone tells you that, oh, if you have cut a string that way, the period would be that many seconds. So we want to determine the length of a pendulum that can achieve a period of 3 seconds. That means I want to know the T and find L. So let's solve for it. Okay, so there's two ways of doing it. The first way is to plug in 3 on this side and then solve for L. The other is to solve for inverse function. So let's just try solving an inverse function. So we'll write this as T. Instead of a function notation, we'll write it as like this. 2 pi square root of L over 32.2. And then you want to solve for L, right? So you would have to get rid of the 2 pi. So get rid of T over 2 pi divided by. So that would be a square root of L 32.2. So in this particular, the original function L has to be positive. It's a length. Well, actually, I think cannot be 0. If you don't have a length, you can't generate anything. So actually greater than 0. So then I'm going to square both sides to get rid of the L, to get rid of the square root. So it'll be T square and then 4 pi square. I have to square the top and bottom. So it'll be L over 32.2. Right? And then I solve for L by L equal to times 32.2 T square over 4 pi square. So this is the function that would let us to find T. I can write it as a function format like this. L of T equal to 32.2 T square over 4 pi square. Now let's put it in. So if we want a period of 3 seconds, so that would be 32.2 times 3 square times 9 over 4 pi square. Put in the calculator. So this would be 32.2 times 9 divided by 4 and then divided by pi square also. So 7.34. 7.3. Do they say it's a meter or feet? They didn't say. I think it's feet. So if you have something that it has a feet, 7.3. Wow, 7.3 will be longer than a person height. So and then you swing it. Just let gravity to take care of it. It would swing 3 seconds back and forth. Okay, so that is all of 5.7, and our next video will be 5.8.